Hello, 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 everybody! How's everybody doing today? I hope everybody's doing fantastic. Good to see everybody tonight. We're here for the last 102 class for the week. Hopefully everybody's doing great. Alright, we are back. We're gonna get started fairly soon. Let me check on that. It's fine. Go! Perfecto! We'll wait for a few more people to come in, and then we'll be good to go. Do this. There we go. That works. Alright. I see a few people in the chat here. I see, let's see who I see. Bill. I see Bill here in the chat. Hopefully gotten through all the ads and stuff. Alright, I got the page there. Alright, that's good. Good to see everybody. Woo. Get ready, get this section out of the way, and we'll get going. Just that easy. At least I think so. At least I think so. Hopefully you have, maybe you have plans for this weekend and stuff. I don't know. But, you know, get going here very, very shortly here. We'll do, maybe a few minutes, so. A few minutes here. Hopefully we'll have the rest of the crew kind of join us here. Let's see, what's this? Okay. Those stamps. No. Alright. Alright. See, anybody else gonna be here? Bill. That's about it for right now. Alright, give me just a second, guys. I'm going to go grab something to drink. I will be just back in a moment. Okay. Oh, got a few more people came in. Good. Excellent. Excellent, excellent. Alrighty. I think we're about ready to start here as we got a few more people that have joined us so very kindly. did this today. Okay, let's do this. Right. Drink a little tea. Woo. All right. It's cold. All right. All right. We are here. We're gonna go get started here in just 1 minute. All right. So just a minute here, and then we'll go ahead and get started here with the new material. We will get going. All right. I promise you, it won't take too long today. We're just gonna go ahead and start here with a brand new chapter. We're almost there, guys. We are almost there. If you'll believe it. If you will believe it, we are almost there. Excuse me. Right here now. Shoot. Hey, happy Friday Eve, Hornets, to you as well. I hope things are very good on your end, Hornets. Hopefully you've had a nice, wonderful day already. How are you doing tonight? All right. All right, ladies and gentlemen, let's go ahead and get started here with the new material here for today. All right, let's get going here. We're gonna be in good shape. I think we'll be in good shape. Move this over here. That'd be a good idea. All right, let's do some intros. Let's get going. Okay, let's get started with today. Welcome back to Thursday, end of the week time today. So today, ladies and gentlemen, we let's recall what we did here last time. Last time we did the end of chapter 10, which was hypothesis testing. Today we are going over to the last section of last chapter here of the textbook. We're going to go from chapter 10 over to chapter 4. Okay, so we're going to be starting chapter 4 here today. Chapter 4 is a nice little bow on a lot of generic topics that we've talked about throughout the course of the semester. So it won't be tying too much, but again, a little bit of this and a little bit of that, just tying up a lot of big picture things that we've discussed here so far. And just a couple of little itty-bitty pieces will be what chapter 4 is all about. It's actually pretty nice and relaxing. It's not as bad as you may think. Alright. Tomorrow is a new day. Tomorrow is a new day. Tomorrow is a new day, and hopefully that day is better than the previous one. Alright. So let's go ahead and talk about chapter 4 here. So what exactly are we talking about here? Well, we need to go to the big board here in order to understand. If I have a big board, let me hit hello. Hello, big board. Yeah, that thing. It's going to be cool. Yeah, there we go. Alright. So here is our big board example. Alright, here is our big board example. It's not as hard as it may look, but still, let's go ahead and talk about it here. We'll discuss exactly what you see here on the screen. We'll see exactly what to do. Alright. Now, turning this down would be the first thing I would do. It's pretty loud. There we go. Alright. So, as we can see here on the screen, let's talk about, what we're going to talk about here today is we're going to talk about data sets. And specifically, what we're going to talk about here in chapter 4 is we're going to talk about the relationship between data sets, okay? So that is essentially what we're going to see here. Okay, what kind of relationship can we establish between data sets? So between one variable and another variable here. That is essentially what we want to be doing here. Specifically, we'll be talking about a linear relationship between those two particular values. So the first thing that we need to do to understand is we need to understand what is a scatter plot. So a scatter plot is a graph that shows the relationship between two quantitative variables measured on the same individual. So For example, here we have an x-axis and a y-axis, okay? The x-axis we call the explanatory variable. All right, so it'll help explain what's happening here, all right? Like an input, if we talk about it from a basic perspective. All right, if we talk about, then we have a y-axis. Of course, that's the response variable. So if we input something, we get a response back, okay? So again, the example that I've put down here is like caloric intake and BMI. BMI standing for body mass index. So again, the more calories you could intake, the higher the BMI a individual could have, okay? So if you have 2,000 calories, okay, you may have a BMI of, I don't know, just make up a number up, 30, okay? So you have a BMI of 30, fine, there it is, pretty easy, okay? Now we want to explore, based on the data that we're given, exactly what kind of relationship and specifically how strong that relationship is going to be. Now, take a look here at the paint screen here off to your right. I kind of did this in the class before, but drawing this takes a while too. So this here would be this first example you see up here, this guy that I'm going to circle in red. This guy here is our example here of a scatter plot. Okay, so this is a scatter plot here. Here we have an X, we have a Y, okay, and we have some random points in and around X and Y. It's just scattered all over the place. Sometimes they're going to make a pattern, and sometimes they won't, okay? But that will help us explore exactly what the difference is between both of those things here in this particular case, okay? So that is essentially what the scatter plot will do. All right. Okay, so let's talk about, with the scatter plot here, let's talk about what comes next, okay? We'll come back to this, of course, in just a second. All right, but let's look at question 2 here. Question 2 asks, what can a scatter plot show in terms of relation between two things? Okay, so what can a scatter plot show in terms of a relation between two things? Now, I didn't put anything down here for this question. And I did do this on purpose here because you'll see what I put here over to the right will make a whole lot more sense. So to put it into proper context and put to a visualization for what I'm talking about here in terms of what a scatter plot shows between the relation between two things, I'm going to hold off doing this question for right now, but we're going to come back to it fairly soon, okay, today. I promise you, we're obviously going to answer this question here, but you're going to see exactly how the scatter plot can show in terms of the relation between two things and see how that generally works. All right, so we have that. Okay. Now, in order for us to understand this relationship between two things, in this case, X and Y, all right, let's look at question 3 here. So, we need to talk about this very carefully. It says, how do we find the sample linear correlation coefficient? So we need to find a particular guy. This particular guy here is the sample linear correlation coefficient. Now, I know this is a very long and ugly formula. As you can see here, there's a lot of moving parts here in this particular formula. Now, before you start writing stuff down, I would ask you to please stop. You do not have to write this down, nor do you need to memorize it. I have put this down for the sake of completionism for the notes, but you do not need all these pieces here, as again, we're going to let the calculator solve that for us in our stead, okay? Obviously, as you can tell here, this is a really ugly looking formula. Again, you have xi, which are all the data items, yi, all the data items. You have the means for the x's, the means for the y's, the standard deviation for the x's, the standard deviations for the y's, and the sample size. Pretty ugly stuff, I know. Some of these are pretty easy to get, but some of these, you have to add that all together after multiplying and all that stuff. And, well. Anyway, the most important part here as part of this formula, of course, is something you do need to take away from this, and that is specifically the correlation coefficient. That is labeled as the letter R. Okay, so the letter R here represents our correlation coefficient. Okay, and we will be figuring out how to solve for R here with using our calculator in a given example. Okay, so you'll see exactly how that works. We'll be going through that together, and we'll see exactly what happens when we do. All right. But before we do that, we do need a few more pieces of information, so let's talk about those. Let's look at number 4. Number 4 says, what are some properties of a linear correlation coefficient? So the first thing that you have to understand is what R can be at the end of the day. what exactly could r equal to at the end of the day? So r here, the linear correlation coefficient, has to be between -1 and 1, all right, including -1 and 1. All right. Now, each of these has a very particular important meaning, I should say, behind it. All right. So again, r has to be between -1 and 1, and a negative value for r here indicates a negative linear relationship. And a positive r here, a positive value for r, will indicate a positive linear relationship. Okay? So negative r indicates negative linear relationship, positive r indicates a positive linear relationship. Okay, now why is this important here? Well, let's take a look at number 5. I know this is kind of going a little fast, but I'll slow it down here a bit, so in just a second. The last property here is in relation to what you see here in number 5. That talks about how can we interpret the linear correlation coefficient. So the basic way this works is that the closer r is to 1 or -1, the stronger the relationship is between both variables. So if we're getting close to 1, or we get close to -1, then that means that we have a very, very strong relationship, whether that be positive or negative, between x and y in that respect. Okay, a stronger and stronger positive linear relationship or a stronger negative linear relationship. So the question really becomes is how can we interpret what r is and tell you, well, how strong is that relationship between x and y? I've told you strong, but exactly how strong, okay? That's really the important part here. How strong is that thing going to be? Well, fortunately for us, we have a little bit of a tier list here talking about what kind of relationship we have depending on the value of what r is going to equal to. And like I said, we're going to look at an example about how to solve for r here. I guarantee that. Okay, so I know that a lot of things that I'm talking about right now are very abstract. But I just first would like to give you a visual representation of what that would mean for r, and then we'll look at to see exactly how we can solve for r here directly. Okay, so here you see a list. This is like a tier list, okay, so of what r is equal to and what it reflects. So again, as you see there, r is equal to 1 is a perfect positive linear correlation. R between 0.9 and 1, including 0.9, is a strong positive linear correlation. Okay, you get the general idea. But the reason why I have these guys drawn out here to the right is because I want to show you a picture, a pictorial way of representing each one of the tiers that you see here on the left. Okay, so having a picture in our mind to know what that expectation is will certainly prove to be fairly helpful. So let's take a good look here at the first one. We have r is equal to 1, which indicates a perfect positive linear correlation. So the way it works is it works like this. Here you have basically a scatter plot that basically goes up, and you could basically think of it this way. Imagine if you draw a line on the graph and it literally goes through every single point on that graph. That would be an indication of a perfect positive linear correlation. Before we move any further here, let me actually do this here. Are there any questions so far, by the way? Sorry. Maybe I'm going too fast. Just let me know. Any questions so far, guys? No? You guys have it. If you have any questions, just let me know, and then I could certainly explain things there. All right. Rolling no questions. Okay, that's fine. No. Okay, Saber says no. No. All right. All right. So let's go ahead and take a look here at the next one. So the next one I put down here is we have a strong positive linear correlation. So that's where r is between 0.9 and 1, including 0.9. And you see that basically the scatter plot here is a little bit more spaced out. It's just a little bit apart. Again, they're pretty close together. Like you could make a perfect line, but you can't. You can't go through every point, but it's pretty close. Okay, so it's a little, the scatter plot here is a little bit more spaced out, but again, you can see that it does form a line of some kind. A weak to moderate positive linear correlation is basically now they're spaced out even more. So instead of being kind of in a narrow window, now you space it out a bit more. They're like in a larger kind of arrow where you can put all the scatter plot. And again, it tends to be positive as the line would go up. Okay, hence why a weak to moderate positive linear correlation. The next one we see here is where r is between negative 0.4 and 0.4. Again, not including those two. But again, that means there's no relationship. Essentially, this is one of the easiest ones, is where all the points of the scatter plot are all kind of dotted around. Okay, there's no rhyme, no reason. It's purely random where they go. They don't really form a pattern whatsoever, so I can't really relate to them. That means there'd be no relationship between x and y. It's just everywhere. The next one here is from negative 0.4 to negative 0.9. So basically, that's a weak to moderate negative correlation. So again, it looks pretty similar to that of the weak to moderate positive. Again, just flip it over. So again, it is going negative, again going down. Okay, but the points are pretty spread out, you know, like this, in this case like this. Okay, going down this way. So here like this. Question. I feel like I'm doing Ginyu Force moves. All right, now let's let's go ahead and there we are. So we have weak to moderate negative is what we have here. All right, next we have a strong negative. That's from negative 0.9 to 1, negative 1. Again, not including negative 1. Again, now the points are more slightly closer together, heading down in a negative direction. So again, much more narrow. Again, you can probably draw a line that goes through many of those points. That's perfectly fine. Then finally, we have r is equal to 1, a perfect negative linear correlation. Again, a line that goes down, you can draw a line that literally will go through every single one of those points, and it'll be perfect in every single way. That is a perfect negative linear correlation. All right, so hopefully this gives you a good pictorial representation, pictorial kind of way to kind of picture exactly what R would reflect in each of those given situations. So if you were given a scatter plot, you'd have a pretty good idea exactly what category they could technically fall underneath. Okay. Let's ask this again really quick. Any questions? Any questions so far? Any questions, guys? Good. All right. Okay, so let's go ahead and take a look at an example here. What we need to do is we need to take a look at an example, and we need to figure out exactly how we can establish a linear relationship between two things. All right, so we're going to go to the textbook here, and I need to go to a particular. All right. So we're going to look at a specific example here. All right. Watch this TikTok. Watch this TikTok. It's so cursed. Well, unfortunately, I don't have people put links in my chat, so I do apologize. We'll do number 17 though. It's not as cursed as maybe that TikTok video. Question mark. But if you're gonna have me watch TikTok videos, it has to be of cats. That's pretty much how it has to be. Just saying. All right. Cat videos, the best videos. Better be the best cursed cat video ever. Man, cat videos, that's where it's at, bro. Where it's at. So the internet should be for just cat videos. Done. Done, son. Okay. So I'm gonna write down these numbers here for number 17. Alright, let's do this, ladies and gentlemen. Alright, let's look at question 6, I promise you. Question 6. How can we determine if a linear relation exists between two variables using the linear correlation coefficient? Alright. We're gonna go ahead and do this together here. Okay. So, the first thing that we have to do is use the calculator to determine R, the linear correlation coefficient. And we're going to go through this together here. So, I would like everybody here to bust out your calculator. So, please take out your calculator here. I would greatly appreciate that here for this example. Alright? Okay. So, please type TikTok in the chat once you have your calculator out in front of you. Please type TikTok in the chat. Once you have your calculator out in front of you. We're gonna do this right, folks. Perfect. Oh my goodness, this is gonna be so good today. Alright. Alright, great. Anybody else who's behind here don't have their calculator. Okay. Alright, ladies and gentlemen, what I would like you to do first is I would like you to go ahead and hit the yeah, let's do that. Let's go ahead and hit the stat key and go to edit. Hit the stat key and go to edit. Now, if you have stuff in your lists here, what we want to do is to clear out these lists. We're going to highlight the list, hit the clear key, and hit the enter key. That will help us clear out all them lists all at the same time. Alright, and we'll clear out this list here. There you go, all those guys are gone. Okay. Now, in list number 1 here, I would like you to enter in all the X values that you see here on the screen to the right. So we have 2, 4, 6, 6, and 7. And the Y values for 8, 10, 13, and 20. Alright. Alright. Alright, and once you have all those values entered in, please type done in the chat. Please type done in the chat. Once you have all those numbers entered in. Alright, so I'll wait for everybody to get all these values put into their calculadoras, and then we'll move forward. Alright, Sammy, Strolling, Bill, and Rita, and Shanla. There we go. Okay, everybody is GTG, good to go. Alright, so let's go ahead and see what we gotta do next. Alright, perfect. Alright, so next, what we're gonna do here is we're going to quit to the main screen here. Alright. Now we have all our numbers entered in. Normally we would do something, we would do the process here, but before we do that, we have to do something here very important, okay? If we're going to get R to show up on the calculator, okay, actually, let me preface it by saying this. R cannot show up normally on the calculator, okay? Unfortunately, it is not set as a default value to show up at all on the calculator. we actually have to tell the calculator to show R on when we try and compute it out. Otherwise, we won't be able to solve this problem at all if we're going to find our correlation coefficient R, okay? That will not be possible whatsoever. So that's one thing to keep in mind here in regards to this particular process. Now, I'm going to put this in the chat here, okay? So you only need to do this once, unless you change batteries or hard reset, i.e. Clearing the RAM. So what I'm going to show you now, you only need to do this once, unless you change the batteries or hard reset. That means, that doesn't mean like turning it off and on. That's not hard reset. I'm talking about actually clearing the RAM and doing like second plus stuff on the calculator. So I want to talk about this now. This is the only time you'll have to do it unless one of those two things apply. So if your calculator dies and you have to switch out the batteries, you will need to do this again. Okay, I'm just letting you know right now. Now, what we need to do here, the particular button presses, if we're going to get to that point, is put this here also. We're going to hit the second key, okay, and the 0 key, okay? So we're going to hit the second key and the 0 key. Do that, second key and the 0 key, and you'll get to this catalog here. So you get the second key and the 0 key. Now, we want to find a specific thing in our catalog, okay? The thing that we want to find in our catalog is, I want you to go ahead and scroll. I want you to scroll all the way down until you find this particular value, this particular option here, which says diagnostic on. Okay, so I would like you to scroll all the way down to diagnostic on your calculator here. So here it is, it's right here. And then I would like you to hit enter twice. And what it should say after you do that, it should say done. All right? All right, so I would like you to type in cursed in the chat once you have the screen looking like what it does on my screen. Once your calculator looks like it. Type in cursed in the chat once we got that going. All right, we got a few people here. Oh my gosh! All right, perfect. I think I might have gotten something. All right. Okay. So we have this all set up and ready to go. All right, perfect. Okay. Okay, so now that everybody's set up and they have this on, we're going to go ahead and do the next part here. Next, what I would like you to do is I would like you to go hit the stat key, and I'd like to go over to calc. I'm going to hit the stat key. I'm going to put this in the chat here. Stat key, I'll go over to calc. And then specifically, I would like you to go to number 4, which says linreg ax plus b. Okay, let me put that there. So you're going to go down to number 4, linreg ax plus b. Now, if you have the new school calculator, what you're going to see here on your screen is what you see here on my screen. If you have the old school calculator, I'll show you what to do here in just a second. Okay. Now, if you have the new school calculator, excuse me, then you have an X list and you have a Y list like you see here on the screen. Now, if you don't have anything listed there, you do exactly want what's already here. You want the X list to be L1. If there's nothing there, though, you can hit second and 1. If Y list to be L2, if there's, again, nothing there, you hit second and 2 for L2. Leave the other things blank, okay? Just leave it alone. Leave everything else blank. Skip the frequency list. Skip whatever this is. And go to calculate and hit enter. Okay, and this is what should show up here. Now, if you have the old school calculator, I'm going to go back and do this one more time here. This is what it should look like on your old school calculator. For the old school calculator here, you should have linreg ax plus b. You should have L1, comma, L2. Okay, so you should have second 1, comma, second 2 for L2, and you should get the same thing that I just had before. Alright. Type in, let's see, type your favorite food in the chat once you have exactly what you have on my screen. Type your favorite food in the chat once you have your calculator matching up with mine. Your numbers are off. Oh. Let's go back and make sure. Check the numbers on the right here. Go back to your list there, Strolling. Make sure your numbers are correct. Your numbers are off. Alright, guys, let's take a look here. Let's go back to our list. Chimichanga. Make sure you have exactly what you have on the lists here. 2, 4, 6, 6, and 7 for L1. 4, 8, 10, 13, and 20. Okay. Make sure you have those numbers there properly. Okay. Did you put L1, comma L2? Because your numbers should be matching mine. That's how it should work. Remember, you hit the stat key, go to calc, go to number 4. Not number 8, number 4. So use number 4, linreg ax plus b. There are 2 linregs, I know. But you go to number 4 and not number 8. And it should be L1, comma L2. I hope we got that right. Tacos, perfect. No, frequency list should not have L2. No, you should delete that. Delete that. Strolling, that's the problem. That's the problem right there. Now I see what the problem is. This should be blank. You should have nothing in there. It should be L1 should be your X list. L2 should be your Y list. Then you should have nothing in your frequency list. And just delete whatever. If there's stuff in this, delete them. Okay, just delete them. This is exactly what it should look like when you do linreg ax plus b, okay? Should have nothing in there. X list is L1, Y list is L2. Okay? Sammy says tacos. Bill says chimichangas. Alright, Strolling, did you get the numbers here? You gotta tell me your favorite food. Sanla, same with you. Alright? Tell me your favorite food, Strolling. It's important. Salmon. Ooh, salmon pretty good. Salmon is pretty good. Cheeseburger. Can't argue with that. Nothing wrong with the classics. Maritza. Ramen. Ooh. Well. Ramen sushi. Ooh. People after my own heart, man. Shoot. I just had ramen on Monday. I can't really argue with that at all. Well, actually, I have ramen pretty much every Monday, to be honest. All right, very good. Everybody is on board. Excelente. All right, great. Now that we have all the button presses, we're all good to go. We're getting hungry here by the end of this lecture. I promise you that. let's go ahead and write down what R is. R here in this case is 0.8958. Okay. I already am. Wahaha. You see, this is what makes math teachers so amazing. The art of manipulation. Alright, anyway, I digress. I use mathematical psychology, and I destroy all sense of reasoning when I make you just as hungry as possible. It says if you're not hungry for knowledge, I'll make you hungrier in other ways. All right, so not a problem. Right. I mean, all right. All right. Now, as you can see here on the screen, if we didn't do this properly here, you would not see these last two numbers that would actually appear on the calculator. So this r squared and r, you would not see these last two numbers at all. That's why we went ahead and did the diagnostic on thing. These two numbers would not appear whatsoever if we actually went ahead and did this process without doing that the first go around. Again, you only need to do that once. That will be the only time you need to do it, unless you have to change the battery or hard reset. Now, let's talk about the next part here. We'll talk about r squared here, by the way, a little bit later, as well as the other numbers. So they'll have a meaning, just not in this section. All right. Now we're done with this here. But what we have to do with r here, what we have to do with r is to basically, in the question itself, the actual handout question, it says we have to determine if a linear relation actually exists. So remember how it works here. The reason why we have to, okay, we could say r here, if we look at it from a, just a point of view, it is a very close to a strong relationship, a strong positive relationship between x and y. Okay, it's close to 0.9 here. It's what we would consider moderate, but it's really close to being a strong relationship here, just by definition. But it's a moderate positive linear relationship. However, does a linear relationship really exist? Now, again, this kind of goes back to something we talked about here, and that really comes down to sample size. Remember, if I ask 10 people a question about, if they like something or not, well, 10 people's opinion about something that they may like or not does not reflect the actual opinion of, say, the entire population of a city or the entire population of a country. It doesn't make any sense whatsoever. Okay, 10 people's opinions mean absolutely nothing. It doesn't lend any credibility. Okay, you probably would want to ask 1,000 people. That would lend a lot more credibility than just 10 people, which is definitely not enough. All right, it's too random in nature, okay, and it's too few to actually gain an actual tangible result. Well, that's what we kind of have to establish here as well. Can we actually justify a linear relationship here between x and y? Now, so we go through these 3 steps here in order to actually determine that. All right, so let's go over these 3 steps here carefully, and we'll see how it works. So, step 1 here is to find the absolute value of the correlation coefficient. So the absolute value here is 0.8958. Now the absolute value of anything just automatically makes that number positive. Even if it's positive, it still stays positive, so that's fine. Alright, so I know it's a little asinine to put down, but still, there it is. Okay, just for the sake of notes. Alright, so there's the absolute value of r, 0.8958. Perfect. Alright, step 2. Step 2 is to find a critical value that directly associates with the sample size using the online appendix A, which we'll get to, or a table given in problem in the homework. So sometimes I'll give you a table in the homework. It's that little blue bookmark that you can probably press on there. Or there is a table in the back of the book on A-2, which we'll look at here in just a second. Now, before we do that, though, let me ask you guys a question here first. First and foremost, what is my sample size according to this problem? So according to this problem here that I have, number 17, what is my sample size according to this problem? Strolling says 10. Bill says 10. Maritza says 10. Egat says you want to become famous. I said yes. I do want you to become famous. Thanks, bro. Record time for being banned. Thank you very much. Alright. Anybody else? We have 10. We have 3 10s. So Strolling Bill and Maritza all say 10. Horit, Sanla, what do you guys think? Sammy? What do you guys think? What's our sample size here? What do you think? Alright, Horit says 5. Alright, Sammy, Sanla, tell me what you think. Do you think it's 5? Do you think it's 10? Do you think it's maybe something else? Well, I can tell you right now, one of those is true. All right. So let's go ahead and go over. Let's go ahead and go over what the answer is. What is the actual sample size here? Remember how a scatter plot works. A scatter plot is basically a point between x and y. All right. So essentially, the way we want to read this is each one of these should be a point as well. So in effect, this first guy here would be the point, say 2, 4. This would be like 4, 8 if I were to put it on a graph, for example. In fact, we have 5 of those said points on the scatter plot. So in fact, you are correct, Horitz. The actual answer is 5. The sample size is 5 here and not 10. This is why I asked the question here, because it will be important for what we want to do next. I want to get the correct perspective here, at least in this case. All right. So we have 5 here to be our 5 here to be our sample size. All right. So nice job there, Horace. All right. Now, let's go ahead and take a look here at the back of the book. So we'll look at A-2, and you can find this in the book. And we're going to grab a critical value that's associated with the sample size of 5. So the sample size of 5 here is going to be 0.878. Okay, so we're going to write that down here. The critical value is 0.878. Okay. Now, if that's true, let's look at the last step here. See exactly how this works. Oh, wow. I am not shocked. Alright, so let's look at the last step here. We'll come back to this guy shortly. Alright, so now we want to make a comparison. It's very similar to the comparison that we talked about here in hypothesis testing. Okay, so we're going to compare what we got here. It says if the result of step 1 is bigger than the critical value found in step 2, then a linear relation exists between the two variables. If it isn't, well, too bad, so sad, it doesn't exist. So the question we have to ask ourselves is this. Is 0.8958, what we found in the first part, bigger than 0.878? Yes or no, is 0.8958 bigger than 0.878? Yes or no? All right. Well, definitely the answer is yes, okay? So if the answer here is yes, okay, then we can say, since the answer is yes, then a linear relation is going to exist. So that is going to be our conclusion for that. All right, and that's all we generally care about. Okay, good. All right, any questions about that example? Any questions? We're going to be doing another example, of course, but just making sure everybody's on the up and up. Oh, I moved too fast. All right, good stuff. Okay. All right, let's try another problem then in the book. All right. All right. We're going to do this next one here. This will be from our number 25. Okay, so let's do 25 here. Okay. All right, so let's go ahead and read this off here. The Gallup organization regularly surveys adult Americans regarding their commute time to work. In addition, they administer a well-being survey. According to the Gallup organization, the Well-Being Index Composite Score is comprised of 6 sub-indices: life evaluation, emotional health, physical health, healthy behavior, work environment, and basic access. All right, and here they give us a table, a complete descriptive of the blah, blah, blah. Here's the data is based on the results of the survey. So they have the commute time here, and of course they have the index score here, there on the right. Okay, so what we want to do is, of course, find out if a linear relation exists between the commute time and this index score that we see right here. So we're going to go ahead and figure that out right now. I'm going to put this off here to the right, and let's go ahead and do this together on the calculator, okay? And let's put it all together. All right, so let's go ahead and hit the stat key here, and we'll go to edit. Let's clear out our old lists that we did from our previous example. Clear and enter. And scroll over here, hit clear and enter after highlighting the list. All right, let's put in our commute times in list 1. And let's put all the well-being scores in list number 2. Okay, good stuff. Nice, nice. Right. All right. Type done in the chat if you have all your numbers entered in, and we will do the next half. Let's just see if everybody's on the same page. Hopefully they all get the same answer. Let's see if everybody's good. So if you have this entered into your calculator, please type done in the chat. Alright. Horit, Strolling, Bill, Sammy, Sanla. Alright, we're good. Maritza's good. Okay, very good. Alright, so everybody's good. Alright. Everybody's good. Perfect. Alright. Let's go ahead and second in mode. We'll quit to the main screen. Again, this just ensures we don't enter anything bad. Alright. We'll go ahead and hit the stat key here once again. We'll go over to calc, go down to number 4, which is linreg ax plus b. We'll leave everything alone. Go to calculate. Again, remember for the old school people, you have to linreg. Let's put this one more time. Remember linreg ax plus b, L1 comma L2. Okay. Remember for the old school calculator people, that's how you have to put that in. So, please type cheese in the chat. Please type cheese in the chat if you got these same exact numbers that I did on screen. All right, Horrid Strolling, Sanla with the 90s reference of cheese. Bill and Maritza. All right, who are we missing here? We're missing one more here. We're missing Sammy. Let's make sure Sammy's got that. All right, Sammy's got it perfect. All right. Excellent. Man, that was the 90s for you. Everything had to end in Z. That was kind of the rule. Or apostrophe N. All right. Or just N. All right, now let's take a good look here at R at the very bottom. All right, so R here is equal to negative 0.9805. Okay, so now we're going to see if there indeed is a linear relation between commute time and the well-being index. Let's go ahead and take a look. And we're done with the calculator now. So again, taking in step 1 into account, we go ahead and just find that absolute value here. The absolute value of negative 0.9805. And again, in absolute value land, everything is positive. So therefore, we have 0.9805. All right. All right. Now, let's take a look here at step 2. All right, step 2 is we want to find that critical value. So according to the book problem here, let's go bring back the book for just a moment. What is our sample size here? What is our sample size here according to the problem? All right, so you guys help me out with this. What is the sample size according to the problem? Seven. Okay, that is correct, Strolling. The answer is indeed 7. 1, 2, 3, 4, 5, 6, 7. 7 points on the scatter plot. If we had one, that is correct. So let's find the critical value here in the table associated with 7. All right, so we'll have to reference back to the book here because I need to find it. All right, so let's go back to A-2 and go check it out. All right, and so the critical value here associated with n is equal to 7 is 0.754. All right, perfect. All right, very good. Okay, so we're good there. Let's go to step 3 here. Now we have to ask the question here. Is 0.9805 is 0.9805 bigger than our critical value of 0.754. So is 0.9805 bigger than 0.754? Yes or no? Yes, okay. So because the answer is yes, a linear relation will exist. Good. All right, and that's it. Any questions about section 4.1, ladies and gentlemen? Any questions at all? No. With the long ooh. All right. If there are no more questions here, I want to thank you, Nate. Thank you, Horitz. I appreciate that. I want to thank you all for coming on out here to the stream once again. All of you are absolutely fantastic. Great job, everybody. You guys are really killing it out there again today. I don't know about you, but this has been, in this class, has been one of the most, you guys have been really productive this week. You guys have been on top of everything. I don't know what to say, but it's been very, very good to see. All right. So that'll take care of section 4.1. We'll continue hopefully to kill it next week. Getting out a few more sections and whatnot. All right. So yeah, we'll hopefully just knock them out of the park and we'll be set to go. So we're gonna do. All right. So thank you very much, everybody. Once again, I love you all. Oh, you all are absolutely fantastic. And as always, everybody, stay safe, stay healthy, and most importantly, stay sane. All right. Thank you. Thank you very much. Thank you, Maritza. Thank you, Sammy. Thank you, Horitz. Thank you, Bill. Thank you, Strolling. Thank you, Sanla. Thank you, all of you, for coming out here today. You guys are fantastic. Have a wonderful weekend, everybody, and we'll be right back here on Tuesday, okay? Right back here on Tuesday. Have a great weekend. Take care of yourselves, and we'll see you later. Take care, everybody. All right. Bye. Bye, everybody. Have a good weekend, Sammy. Have a good weekend.